Hey guys, I'm Ashwell the Brilliant, and you're watching Learn with Ashwell, and I'm happy to have you with me on this journey of knowledge. And I'm sure my video about Introduction to Quadratic Equations was helpful and would have made things easy. In new videos, we'll build on it and ultimately connect it to real life scenarios, and that's when you'll have that missing link that you're looking for, and you'll be able to connect to the subject and wait for new videos, just like you wait for the new episode of your favorite drama series and would like to know what comes next, what happens next. And that's when there will be interest, there will be more understanding, there will be better studies, and hence better grades. And yeah, topic intro videos will be extremely important, as I said before, because they'll contain details on the theory and background of the topic, and that will build up your concept and make the exercises like a cakewalk, meaning really easy basically. and what else? Our today's topic is solutions to quadratic equations, and today we'll try to learn the different ways in which we can solve quadratic equations, and yeah, so let's get going.
So there are a couple of methods of solving quadratic equations, and the first method is the factorization method. Factorization. And the factorization method, first of all, let me write the standard quadratic equation, the standard form of quadratic equations, which is ax squared plus bx plus c equals 0. So this is like the generalized standard form of quadratic equations. And the first step in the in solving a quadratic equation using the factorization method is that you need it in standard form, which is this type of form. So if you have something like 5x squared plus 3x minus 2 equals 0, that's standard form, meaning like at least 0 is on one side and the rest of whatever it is, whatever you have, like you have x squared, you have the x term, you have c. But like obviously there has to be an x squared, but like there could be 0x, or there could be like 0 as in the c term is 0, the constant is 0, like that. But yeah, if there's an x squared, then it's a quadratic equation. So what you gotta do is you gotta multiply the coefficient of x squared, which is a, and the constant, which is c, together, and whatever their product is. Over here, since we're just multiplying a and c and we don't really know their values, I'm just going to write ac. So this is the product for now, and whatever the product is, you got to split bx into two terms, which when you multiply their product is AC, or is equal to AC, and their sum, when you add them together, they sum up to bx. Okay, so let's say that there are two terms that you split them into two terms. They are L and M. So the rule is that like L and M are not like that's only their value. Like L and M can be like, if you split, say 5 over here, there's 5x, and you have to split it. And just saying, generally you just split it into two terms, like 2x plus 3x, which basically equals 5x. So like 2x can be the L term and 3x can be the M term, so like that. And the rule is that first of all you got to have it in standard form. Second, when you multiply it, the product is whatever AC is, you got to split bx into two terms, and basically L plus M must equal bx, and L multiplied by M must equal AC, meaning like LM basically must equal AC. Now, let's understand this better with an example. So the first example that we're going to solve using the factorization method is 3x squared minus 6x equals x plus 20. Now, as you can see, we need it, first of all, we need it in a standard form, and to do that, you can see that these terms, they're, first of all, like 3x squared is the biggest term over here because it has the x squared in the first place, and second, its coefficient is the biggest, like it's 3. I mean, there is only x squared, like one x squared term over here, but like if there were more, and like if there was something like 2x squared, then you would take the 2x squared to the like 3x squared because 3x squared is bigger and it's positive. So in this case, we're going to take x to the other side and we're going to take 20 to the other side, and we'll get 3x squared minus 6x minus, when x goes to the other side, it will become minus x because its sign will change. So will 20 is plus 20, so it'll become minus 20. And it will equal 0. And as you can see over here, the terms 6x, minus 6x, and minus x are like terms, so we can simplify them, and we can write them as 3x squared minus 6 minus 1 is minus 7, so minus 7x minus 20 equals 0. So there we go, we have it in standard form. Now the next step is that we need the product of AC. So AC equals, now we have to multiply the, like AC, in AC, A is the coefficient of x squared and C is the constant. So 3 over here is the coefficient of x squared and minus 20 is the constant. So we multiply 3 with minus 20 and we'll get 3 20s are is 60, so minus 60 as one of them has a minus sign. So we got the product of AC, it's minus 60, and now we're gonna factorize it. So like the factors can be 1 and 60, they can be 2 and 30, they can be 3 and 20, which we have right here actually. They can be 4 and 15, they can be 5 and 12, 5 and 12, and they can be 6 and 10. And after this, the factors just repeat. It'll be 10 and 6, 12 and 5, 15 and 4, etc., etc. So these are the pair of factors. Now, out of these pair of factors, we need to find the pair whose sum is minus 7 and whose product is minus 60. Now, before we jump into the pairs, I want you to look at one thing. Over here you can see this is 3 and this is minus 20, and it gives us minus 60. So like what I'm trying to say is that over here, one of these two are factors which are giving us minus 60, and one of them is negative, so and the other one is positive. So that means that like the two terms that we're going to split this minus 7 into the x term into, one of them has to be negative and the other one has to be positive. It basically just depends on their these factors, their sign. So if both of them are negative, then both the factors of the x term, both the terms in which the x term will be split, will both have a negative sign. If one of them has it, then one of them will have a negative sign. So like that. Now, and if both of them are positive, obviously both of them are going to have a positive sign. So now we're going to look at this. We're going to look at the pairs. So just saying, for example, say that like 1 and 60 is the right, is a pair, but we don't know which type of combination works. So it can either be, it can only be like two things. It can either be -1 and 60. In that case, we'll have like 59, and either it can be 1 minus 60. In that case, we'll have minus 59. But in both cases, we know that's not going to work out. So that's not an option. 2 minus 30, that will be minus 28. And 30 minus 2 will be 28. So that's not an option either. 3 minus 20, that will be 17, minus 17, and 20 minus 3 will be 17, so that's not an option either. 4 minus 15 will be minus 11, and 15 minus 4 will be 11, so that's also not an option. Now 5 minus 12 is minus 7, so that's the one that we're looking for. And yeah, we can just cross out the other one, 6 and 10, because we don't need it. So yeah, we're going to be splitting minus 7x into two terms, which are going to be 5x and minus 12x, because 5 minus 12, that's the one that we chose. That's the one that it's going to work with. It's not going to work with minus 5 plus 12x, because that will be 7x positive. So yeah, writing it again, 3x squared plus 5x minus 12x minus 20 equals 0. So over here we can take x common, so we'll get 3x plus 5. And over here we can take what's called minus 4 common, and we'll get 3x plus 5, and it equals 0. So now let's just move down a bit, and we'll get 3x is common again, so we'll take a common, 3x plus 5, and the other one will be x minus 4 equals 0. So now these two factors, they basically give us the equation. The equation was 3x squared, I think, what's it, minus 7x minus 20 equals 0, right? Yeah, right over there. So, and as you can see, like basically it's still true, like it's equal to 0, they're equal to 0. So now these two factors give us this equation, and they equal 0, their product is 0, at least that's what the equality says. And since it's true, the equality obviously has to hold, right? So that means that one of these factors has to be 0 for the equality to hold, because if one of them is 0, then when it multiplies with the other, then it'll be 0. So we don't know which one, so we're going to just say either 3x plus 5 equals 0, or x minus 4 equals 0. So in this one, we can take 5 to the other side, and we'll get 3x. When 5 goes to it's positive 5, so when it goes to the other side, it will be negative, so negative 5 minus 5. Or in this one, we can take minus 4 to the other side, so we'll get x equals plus 4, like it's minus 4, so it will become plus 4. And over here, we can either you can say we can divide 3 on both sides, or we can just say, if you understand better, then we can just say that like we can take 3 to the other side. Simple. So yeah, over here 3 and 3 will cross out, and we'll get x equals minus 5 over 3. So that's the value of x, and again we got two values because it's a quadratic equation. So x, y, they're equal 5 over 3 or 4. So that's our solution set. Now let's solve another question, another equation using the factorization method. So let's say we have 2 over x minus 9 equals 1 over x minus 3 minus 1 over x minus 4. Now what do? We can't really tell if it's a quadratic equation in one sense. So what are we going to do? We're going to simplify this using mathematical operations to get what we want. So what we want is x squares to know if it's a quadratic equation. So there are fractions involved, as you can see, and for fractions you can do two things. You can either like solve, like there are fractions on both sides, so either you can solve like a fraction, you could say like this on the right hand side there are two fractions, so either you can solve these individually, like individually the sides, so like this can be solved, the left hand side can be really solved. So the right hand side, you can see you can solve this by taking the LCM, and yeah, you can then send a denominator, whatever the LCM comes, it'll be the denominator basically, and you can send a denominator to the other side, and you can do it like that. Or we can take the LCM of the equation, of the whole equation, LCM of the equation, which is basically all the denominators, the product of all the denominators. You multiply it with everything, and you'll get your result. You'll get rid of the fractions all at once. So we're gonna do that, and the LCM of this equation will be x minus 9 into x minus 3 into x minus 4. Yeah, actually we'll write it down here. So we'll have x minus 9 into x minus 3 into x minus 4 into 2 over x minus 9 bracket equals x minus 9 into x minus 3 into x minus 4 over 1 over x minus 3. And as you can see, there's not enough space, so we'll just move down over here. We can write the next part, which will be x minus 9. And there's a minus over here in the middle of the 1 over 3x minus 9, minus 3, and 1 over x minus 4. So we'll get x minus 9 into x minus 3 into x minus 4 into 1 over x minus 4. Now, as you can see, some things can cross out. Over here, 9, x minus 9 and x minus 9 can cross out. Over here, x minus 3 and x minus 3 can cross out. and over here x minus 4 and x minus 4 can cross out. So we can write 2 into x minus 3 and x minus 4 into x minus 4 basically, and equals, this will be, there's 1 over here, there's no point of multiplying, but I mean, like, you could just say you multiplied it and it'll just be 1, it'll be the same thing. So you get x minus 9 into x minus 4 minus this minus, and you'll get x minus 9 into x minus 3. Yeah. And let me just try to separate this, so this is just different. Yeah, so now we can solve this. Just write this 2 as it is, 2, and when you multiply x with x, you get x squared. When you multiply this x with minus 4, we'll get minus 4x. When we multiply minus 3 with x, we'll get minus 3x. When we multiply minus 3 with minus 4, we'll get plus 12. And there'll be a bracket right here. Equals, over here, x again into x. We'll get x squared. Then x into minus 4. And we'll get minus 4x. And minus 9 into x, and we'll get minus 9x, and minus 9 into minus 4, we'll get plus 36, whole in bracket. Then we have this minus, we write this minus over here, then we have x, this x will multiply with x, this x, and we'll get x squared, and then this x will multiply with minus 3, and we'll get minus 3x. Then minus 9 will multiply with x, we'll get minus 9x. Then minus 9 will multiply with minus 3, which will be plus 27. As minus and minus, when they multiply, they'll make plus, and 9 3s are 27. So yeah. Then we can simplify, as you can see over here, we can simplify minus 4x and minus 3x. We can simplify minus 4x and minus 9x. And we can simplify minus 3x and minus 9x over here. So by simplifying, we'll get 2x squared, 2 into x squared basically. Minus 4 and minus 3 will be minus 7x. This will be plus 12 over here. Into, so there's a bracket here, equals, there's x squared. Now minus 4 and minus 9 is minus 13, so we'll get minus 13x, and this will be plus 36, still in bracket. Then there's this minus, then we have x squared again. We have minus 3x and minus 9x, so that will be minus 12x plus 27. Now we're going to multiply 2 over here on the left hand side. We're going to multiply 2 with x squared, we'll get 2x squared. Multiply 2 with minus 7x, and we'll get minus 14x, as the sign is minus over here, and that's plus, so plus minus is minus. And 2 7s are 14, so yeah, minus 14x. Then when we multiply 2 with 12, plus 12, we'll get plus 24 equals x squared minus 13x plus 36. No need for the brackets. Now, when minus multiplies with x squared, we'll get minus x squared. When it multiplies with minus 12x, we'll get plus 12x, as minus minus, when they multiply they make plus, and yeah, plus, then we have 12x, so it'll be plus 12x. When minus multiplies with plus 27, it'll become minus 27, as minus multiplied by plus is minus, so minus 27. And now we can simplify this. As you can see, we can simplify this side. So we can simplify x squared with x squared. We can simplify minus 13x with plus 12x. And we can simplify 36 with minus 27. So we can write this as 2x squared minus 14x plus 24 equals, when x plus minus x squared, like x squared plus x squared minus x squared will be 0, so there's no need, these just cross out. When minus 13 and plus 12 add up, we'll get minus x, and 36 minus 27 will be plus 9. And now, as you can see over here, we can take these to the other side to get the equation in standard form. So we take minus x to the other side, and we take 9 to the other side, and we'll get 2x squared minus 14x plus x. When this x goes to the other side, its sign will change, so it will become plus x. This is plus 24, and when plus 9 goes to the other side, its sign will change as well, so it'll be minus 9 equals 0. Now 2x squared will just come like this, and we can simplify minus 14x and plus x, so it'll be minus 13x. Minus 14 plus 1 is basically 13, so minus 13x. And over here we'll get plus 15 equals 0. And yeah, now this is basically our quadratic equation in standard form. Now we can start applying the rest of the stuff. This was step 1 we got done. So now we're going to use the factorization method again. So we need AC for that. So AC over here we'll have to multiply 2 and 15 as, oh my dear, it's missing the x squared over there. Yeah, so as 2 is the quotient of x squared and 3 is the constant. So when we multiply both of them, we'll get 2 multiplied by 15 equals 30. Now we have 30, that is the product of AC, and now we need to factorize it. So we can factorize it as 1 and 30, we can have like 2 and 15, we can have 3 and 10, and we can have, was it 5 and 6, that's bad, 5 and 6. So now let's look at all the possibilities again. First we're going to look at this. So in this, these are the factors, and like both of them are positive. That means that the terms that we're going to split minus 13x into, they're both going to be either both negative or both positive. and yeah, we have 30. So now let's look at them. So if we have if we take 1 and 30, then if both of them are positive, then we'll have plus 1 plus 30, which will be 31. And if we have both of them negative, it will be minus 1 minus 30, which will be minus 31. So this is not an option. Now 2 and 15, 2 plus 15 will be 17, and minus 2 minus 15 will be minus 17, so that's not going to work either. 3 plus 10 will be 13, but we need a negative, so if we have minus 3 minus 10, which will be minus, 13, so that will be the one that we're looking for, and that means that we don't need 5 and 6. So we're going to split minus 13x, which is the x term over here, into 3 and 10. So we'll get 2x squared minus 10x minus 3x plus 15 equals 0. It doesn't really matter which way you write it. If you write minus 3 first or minus 10, just wrote minus 10. And you can take 2x common from here, and you get x minus 5. And from here you can take minus 3 common, as we want the x to be positive. So we had to take minus 3 common. So when we take minus 3 common, we'll have x minus 5, because yeah, what I want to say is that we want the when we get 15, we want it to be positive, so that's why we had to take minus 3 common and minus 5 over here. So the minus and minus, when they multiply, we'll get minus 15, and when minus 3 and x multiply, we'll get minus 3x back. So yeah, equals 0. And now let's move down a little. So x minus 5 is common, so we'll write x minus 5 once, and we'll get 2x minus 3. And it equals to 0. And now wait a minute, let me just write the equation again. So it's 2x squared minus 13x plus 15 equals 0. And yeah, now these two are the factors of this equation. That means that if we multiply them, we get this equation back. And they both equal 0, this equation also equals 0, just saying. So yeah, it's true. And now their product, what the equality is telling us, what the equal sign is telling us, is that they equal 0. That means that their product is 0. So that means one of these factors has to be 0, but we don't know which one. So we're going to say either x minus 5 is going to be equal to 0, or 2x minus 3 is going to be equal to 0. And in the case of x minus 5, we can just send minus 5 to the other side, and we'll get x equals 5, because minus 5, when it goes to the other side, it'll be positive 5, because its sign will change, so it'll become plus 5. So x will equal 5, or when in the second case, actually, we can take 3 to the other side first, minus 3, so we'll get 2x equals minus 3. When it goes to the other side, it will be positive, so its sign will change, so it'll be positive, so we'll get 3. And then to get the value of x, we can just divide 2 on both sides, or we can say we sent 2 to the other side to get x, and x will equal as 2 and 2 will cross out, so then x will equal 3 over 2. So again, it was a quadratic equation, so we got two results, 5 and 3 over 2. That's the solution set for this equation, for this quadratic equation. That means that these two are the roots of this quadratic equation, and if we use these roots, we can actually get this quadratic equation back, but that's for another video, for another day. So yeah, next let's move on to the next method now, the second method. The second method is completing square method. completing the square method. Let me just make this a little bigger. So, what is completing the square method? Again, first we'll start off with the standard form. For every method, you want to start off with a standard form so that you don't mess up anywhere at all. So the standard form, the generalized one we're using first. So we'll have like ax squared plus bx plus c equals 0. And for this method, step number 1, as I already told you, you need it in standard form. Right, that's done. Clear. Next, what we want is we have the constant term, this c constant. We need to take it to the other side. And we'll get ax squared plus bx equals minus c. That's step number 2. You need a constant on the other side. Minus c is what we'll get because c's sign will change basically. And over here in this example, it's plus, so it's positive, and when it goes to the other side, it's going to be negative. And now, what you need is you want the coefficient of x squared over here. This is important. We need it to be 1 and simple. That's it. We just need it to be 1. And that means that you're going to divide it with whatever coefficient it has. You're going to divide it with like basically everything, you know, to get rid of the coefficient of x squared, unless it's already 1, unless it's something like x squared, something like x squared plus 3x minus 2 equals 0, something like this, then you don't need to. But if there is something like 5x squared plus 3x minus 2 equals 0, then you gotta divide 5 on both sides. So let's get into it. Divide everything with a. Over here, a and a will cross out, so we'll get x squared, meaning like its coefficient is 1 now, plus b over ax, this is the x term over here, minus c over a, this is the new constant term after doing that. Now we're going to use the formula where you remember the formula of a plus b squared. Basically, when you open it, you'll get a squared plus 2ab. Yeah, this looks a little messy, right? 2ab plus b squared. That's what you'll get. But over here, x squared is like a squared, and b over x is type of like the 2ab term, and we want to find the b squared term, and we have these two. So what we're gonna do is we're gonna write x as we're gonna write x just like x squared, like this, plus, because of this, like you see this plus, right? It basically defines what value, how you're gonna write when you sum up the formula, what sign is gonna be after a, like after a, meaning like a plus b squared, or is it gonna be a minus b squared, like that. So over here there's a plus. If there was a minus, then we would write minus over here, but yeah, there's a plus. Now according to the formula, there's a 2, so we're writing a 2, and we're writing this a, this is a, plus from this, basically it's always plus, b squared equals minus c over a plus whatever b squared is, because we want to hold the equality, don't we? So yeah. Now the a term is x is basically a, in one sense you could say. And for the b term, we're going to multiply the coefficient of x, which is b over a, by 1 over 2, so b over a into 1 over 2 to get the value of b, so that we can get b squared and stuff. So we'll get, this will equal b over 2a. So over here it's b over 2a. Now why we're doing this is so that you can see, like, we have b over 2a, we multiply by 1 over 2 as we put 2 because of the formula, so that when we multiply by 1 over 2, this 2 and this 2 can type it like cross out. You can see like this 2 is basically this 2, and this 2 and this 2 can cross out as they're multiplying. Like if I were to write it, this is like basically like this, but I'm just writing it without adding anything into it, like without any values. So to get the value of this, if this is a and this is also a, then so to get the value of b, if we don't know the value of b and we have 2 from the formula and we want to get exactly this term from, like, if we multiply it, then we'll need 2 on the bottom, so that 2 and 2 will cross out from this, and we'll get whatever coefficient of x we use over here. So that's why we can write it like b over 2a when we multiply b over a by 1 over 2, and then this 2 and this 2 will, like, can cross out, but we're not going to really cross it out because we want to sum up the formula. Don't. And then as you can see, yeah. So let me just cut all of this out. So over here we're going to get b over 2a. This is the b term now. Move it down a bit. So now we can sum this up to, like, what is the what is this the formula of? This is the formula, or like when you expand the formula of a plus b squared. So we're gonna write this into this form, and for that we'll get x. X is basically like a. Then there's this plus, the one that defines this, plus this, the one of the 2ab. And then we're writing the b term, which is b over 2a whole square. Oh damn, it looks like it's chopping the head off. The head's off actually. And this will equal minus c over a. When you open this square, you'll get plus b square is b square over 2a squares is like 2a whole square is 4a square. So now what we want is the value of x. So to get the value of x, we'll have to get rid of this square first, so that we can send this to the other side and we can get x, because this is like type of bound within the formula type of thing. So before we do that, let me just x plus b over a, it meaning like I'll write it again, square equals minus c. If we want to gather this up, b squared, we can take the LCM, and we do want to gather it up. So 4a squared is the LCM. 4a squared I'm writing over here. Now we're going to multiply both of these, we're going to divide both of these denominators one by one by this, by 4a squared by the LCM. So when we multiply the first denominator, which is a cancels out with 1a, and you're left with 4a. So 4a will multiply with minus c. Now we have plus b squared. What's going to multiply with plus b squared? We have 4a squared, which is this LCM, and then we have this denominator, this one right here. When we divide it by 4a squared, as you can see, it'll be just 1 because 4a squared and 4a squared will cross out on 1's are. So 1 will multiply with b squared. We don't really need to write that. Pretty sure you can understand. So x plus b over 2a into a whole square equals minus 4ac plus b squared over 4a squared. Basically, when minus c multiplies with 4a, then it will become minus 4ac. Now we can reorder this. We'll get x plus b over 2a whole square equals b squared minus 4ac. We didn't really change anything, just reordered it so that it looks better, as you can see, like with the positive term first, doesn't it? Pretty sure it does. Now we wanted the value of x, so now we need to take the root square on both sides, obviously, so that we will get the value of x. Let me just write this a little bit over here. So when we take the root square, when we take it on the right hand side, we'll need to write a plus and a minus because this is still bad. Because now, like a square, when you have, like, for example, 3 square, and if you have minus 3 square, both of them are going to equal 9. It doesn't really matter, does it? Like the sign when you're taking a square, because a sign, if it's minus or if it's plus, it doesn't matter, because when it gets squared, it's just going to be multiplying with itself. And when similar signs multiply, what's actually happening when you take the square is the same sign is also multiplying. Like 3, what is it called? The number is obviously multiplying with itself, but also the sign is also multiplying with itself. So when it multiplies with itself, is when, like, similar signs multiply, or like signs multiply with each other, they end up in a positive sign. So when minus multiplies with minus, it'll be plus. So like that means that the square can be like a positive or a negative value. So that means that you need to take the square root of like plus or minus. Like it could be plus or minus, so you're going to multiply plus or minus with the square root. So whatever comes out of the square root, it can be either a plus value of that or a minus value, in case it was like a minus square instead of like a positive square, negative square, you could say. So let's further solve this. So we'll get x plus b over 2a, the square is gone because of the square root, equals plus minus, now we're going to separate the square roots, so plus minus 4ac under root over 4a square under root. So yeah, actually, let's just write this again. So b plus x plus b over 2a equals, write this as plus minus b squared minus 4ac, because this really can be solved without the values especially. So yeah, now when you take the square root, 4 is the square of 2, so 2, and a square is the square of a, so 2a. And now as we want to get the value of x, we need to send b over 2a to the other side. When we do that, let's move down, we'll get x equals plus minus b squared minus 4ac under root over 2a minus, when this goes to the other side, plus b over 2a goes to the other side, it will become minus b over 2a. As you can see that their denominators are the same, you can just take them common and they'll just be coming over the whole thing, like they'll just be, you can just write them over the same bar, so it'll be plus minus b squared minus 4ac under root minus b over 2a. And now we can also reorder this, so it'll be x equals minus plus minus b squared minus 4ac over under root over 2a. And there you have it. Now, as you can see, this is a formula of its own, which was basically going to be, what was going to be our third method is basically a simplified version of the squaring method. Write it here. Third method was the quadratic formula, which this is obviously. This is the quadratic formula, and the quadratic formula is basically a simplified version of the completing square method, in where you can just pop in the values and you'll get the result of x, the value of x, and basically it's just coefficients. It's just the coefficients you're just using over here. A is the coefficient of x squared, c is the constant, but like b is the coefficient of the x term, so yeah, it's basically coefficients. And yeah, so that's it. Now let me give you some examples of the completing square method, and then we'll do some examples about the quadratic formula. So the first example for the completing square method I'm going to take is x squared minus 3x minus 4 equals 0. And in this, we'll get, first of all, since we're using the completing square method, the first step is to have it in standard form. It's already in standard form, so that's good. Next, we have to move the coefficient. Over here, the coefficient is minus 4, as you can see. We'll take minus 4 to the other side. We'll get x squared minus 3x. When minus 4 goes to the other side, it will be plus 4. And then we'll start doing the method. So we first take x squared, then we write this minus, this is the minus, this is basically the minus of the 2ab, minus 2ab, like that, like in the a minus b squared formula. So the minus is here. Now we need a 2 from the formula of 2ab, like a squared minus 2ab plus b squared. This is the formula that we're using, which is supposed to be, or is gonna be, a minus b whole squared. So minus 2 is here. Now a is x, so into x, and b, for b's value, we need to multiply the coefficient of the x term with 1 over 2. So when you multiply 3 is the coefficient of x, the x term, so 3 with 1 over 2, you'll get 3 over 2. So we're going to multiply this, 3 over 2. As you can see, when you cancel out 2 and 2, and you multiply 3 and x, you'll get 3x, and when you multiply the minus, you'll get minus 3x, so you'll get the same term back. So that's good, we're going good so far. Now for the b term, so we'll be, this was always will be a plus, as you can see over here, there's a plus, in a minus b and a plus b square, whole square, the formulas. So the b square term is going to be basically this square, so 3 over 2 whole square, that's it, equals the constant, which is 4, which went to the other side, obviously. We're going to add plus 3 over 2 whole square because we want the equality to hold. Now, we can sum this up to x, which is a, and minus, because of the minus in this formula, minus 2ab, that's the decider, which tells you what sign you're going to use over here. So x minus, and this is the b term, 3 over 2 whole square. Basically, this is the same as if you know, like, a minus b whole square. This is basically like that. 3 over 2 is b, x is a, and or like a is x, and there's minus in the middle. And yeah, you have the formula equals 4. Now we're going to expand this, so plus 3 squared is 9, 2 squared is 4, and now we're gonna simplify this, so we can just write like this, equals 4 plus 9. You take the LCM, it'll be 4. 4 is the LCM, and over here, as you can see, there's nothing, so there's 1. So now, first we're going to divide with this denominator, so 4 divided by 1 is 4. So 4 will multiply with this 4 is this, and this 4 is this, so these two will multiply. 9, its denominator is this 4, so when this 4, I'm writing again, the LCM, will be multiplied by the denominator 4, they will cross out and you'll get 1, basically it will be 1. So 9 will multiply with 1, there's no need to write that, so we'll just get equals, when this 4 multiplies with 4, we'll get 16, so we'll get 16 plus 9 over 4, and then this equals 16 plus 9 is 25, so 25 over 4. Now we're going to write that. We got x minus 3 over 2, I believe, and it was the whole square, I think. Let's just check. Yeah, x minus 3 over 2 whole square. Now, to get the value of x, we need to take the square root on both sides so that we can send this to the other side. We can send minus 3 over 2 to the other side, otherwise it won't budge. So, yeah, under root, and over here again we're using plus minus because we don't know which square this might be. And this we're gonna have to write again. So this will be x, the square is gone now, so it'll be x minus 3 over 2 equals plus minus 5 over 2, as 5 squared is 25 and 2 squared is 4, so when you take the square root you'll get 5 over 2 plus minus 5 over 2. Now, to get the value of x, you'll need to send 3 minus 3 over 2 to the other side. When it goes to the other side, its sign will change. It'll become plus 3 over 2. So you'll get x equals plus minus 5 over 2 plus 3 over 2. Now, x will equal 3 over 2, basically the denominator is the same, so you'll just get plus minus 5 plus 3 over 2. Now, you can write this as either x equals plus 5 plus 3 over 2, or x equals minus 5 plus 3 over 2. In this case, x will equal 5 plus 3 is 8 over 2. And in this case, x will equal minus 2 over 2. When you cut this and this, you'll get minus 1 from here. yeah, actually you could just say 1, and this minus 1 multiply with this 1. And over here you'll get 4, so x will equal 4, or x will equal minus 1. So the values are x equals 4 or minus 1. And yeah. So now we're going to take another example of the squaring method. We're going to solve with the squaring method, another example of quadratic equation in real life. So first of all, we have the constant term. We'll take it to the other side. We'll get x squared plus 17x equals minus 33 over 4. So basically, if you get rid of the fraction over here, you're gonna have to get into fractions afterwards, because if you multiply by 4 everywhere and you take constant to the other side, then you need x's quotient to be 1 for this method to work. So you're gonna have to take it to the other side. You're gonna have to divide it anyway, so no point. Now, moving on with our formula, we had a standard form and we took the coefficient to the other side. Now we're going to start with the square, so x squared plus from here and 2 from the formula. Basically, yeah, like plus from the formula as well, but like in a way this is the decider over here. So yeah, then we have the x term, which is, a term, which is x, and we have 17 as a coefficient of the x term, and basically that is going to help us get to the value of b. So we're going to multiply the coefficient of the x term, or basically of x, into 1 over 2, and we'll get 17 over 2. Now if you cut this out, you'll get 17x, so it's good, plus 17 over 2 squared, because this is the b value, so it's square, will be 17 over 2 squared, equals minus 33 over 4 plus the same b value, 2 over 17 whole square. Move it down a little bit, and we can sum this up into x plus, like wrap it up basically, into x plus 17 over 2 whole square. And how is because like x and plus from here, because this is the deciding term, 2ab, and then we have b 17 over 2. That's how. Equals minus 33 over 4. This will be plus 17 squared is 189. No, sorry, I think 289. Over 2 squared is 4. Let's move down a bit. So we'll have x plus, plus 17 over 2 whole square equals 4 is the denominator, so like off both, so we can just write it once, we can just write 4, and minus 33 plus 289. So we'll get x plus 17 over 2 whole square equals, this is 4, and when you subtract you'll get 256. And now we need to take the square root to get the value of x, and basically to send 17 over 2 to the other side so we get the value of x. But before we do that, we need the square root. So we're taking the square root. So we'll get x plus 17 over 2 equals plus minus 256 is the square of 16, and 4 is the square of 2, so we'll get 16 over 2. And when we send 17 over 2 to the other side, its sign will change. It will become minus 17 over 2. So x will equal plus minus 16 over 2 minus 17 over 2. And we can write this as x equals plus minus 16 minus 17 over 2 because their denominators are same again. So now we can write this as either x equals plus 16 plus minus 17 over 2, or x equals plus minus 16 minus 17 over 2, and x will equal minus 1 over 2, or x will equal minus 33 over 2. So our solution set will be x equals minus 1 over 2 or minus 33 over 2. And yes, these are the examples for solving an equation using the completing the square method. We did the factorization and square method. Now we're going to solve two equations using the quadratic formula. So let's start. The first equation we have is 2 plus 9x equals 5x squared. So you can see that we need it in standard form, and over here 5x squared is on the right side. It doesn't matter which side it is on, but I'm just telling you that it's on the right hand side, so we'll have to move the rest of the terms to the side which has the x squared in positive. So meaning, like, if this was minus 5x, we'd have to take minus 5x to the other side, even though it was basically the bigger term. But like, it was in negative, so not really. Now when you take 2 to the other side and 9x to the other side, we'll get 5x squared. 9x goes to the other side, it will be minus 9x. 2 goes to the other side, it will be minus 2, as their signs will change, and they're plus right now, both of them, so both of them will be minus. Now we have it in standard form. Now let me write the quadratic formula, which is x equals minus b plus minus b squared minus 4ac under root over 2a. Now what you can do is you can write the values like over here, the value of a. What is a in this formula? A is basically the coefficient of x squared in general, so the coefficient of x squared is 5, so we'll write a equals 5. Next we have b. What is b? B over here is minus 9, so we'll write minus 9. C over here, what is C? C is minus 2 over here, so we'll write minus 2. C equals minus 2. Now when we write this in the formula, when we put in the values, we'll get x equals minus from this formula. Then we have minus 9 over here, plus minus from the formula again. B squared is minus 9 squared over here, minus 4. A's value is 5. C's value is minus 2. So into minus 2 under root over 2, and A's value is 5, so into 5, 2 into 5. So we'll get x equals, when minus multiplies with minus, we'll get plus, so plus 9, plus minus, 9 squared is 81, minus from this, And then when this minus multiplies, basically like this, I wrote this like this because I know that I can just turn it into a plus, but just like, multiply first though. So minus and minus will be plus, so we'll have plus, and this will be 40, like 10 multiplied by 4 is 40, or like 20 multiplied by 2 is 40, so 40 under root over 10, because 2 and 2, 5 is 10. So x will equal 9 plus minus 121 under root over 10. So then x will equal 9 plus minus 11 over 10. And from here you can just write x either equals 9 plus 11 over 10, or x equals 9 minus 11 over 10. In this case, x will equal 9 plus 11 is 20 over 10, which will equal 2, as this 0 and this 0 cross out, and 2 over 1 is 2. Or it will equal x equals minus 2 over 10. So x will equal, as you can see, 2. This will be basically 1 and 5. So it'll be minus, x will equal minus 1 over 5. So x's value, the solution set we'll get, is x equals 2 or 1 minus 1 over 5. Uh-oh. And yeah, that's the first example. The second is 6x squared minus 3 minus 7x equals 0. So this is basically pretty much in standard form, but we can just organize it again if you want, like 6x squared minus 7x minus 3 equals 0. And now we can write the quadratic formula first. X equals plus, minus b plus minus, I was going to write plus minus first, but yeah. So plus minus b squared minus 4ac, the whole under root over 2a. And yeah, actually this looks a little too long. Just make it a bit like, yeah. So a over here equals, which is the coefficient of x squared, is 6. So a equals 6. B over here equals, is the coefficient of the x term, which is minus c. Actually, you know what? Let's just use another color like this. Minus 7. So b is minus 7. And for c equals minus 3. Minus 3. So now we can just pop in the values and we'll get the answer. So x equals minus from the formula, and then b's value is minus 7. So minus 7 minus into minus 7 plus minus from the formula b squared. So you can see b's value is minus 7 again, so minus 7 squared minus from the formula 4 from the formula. A's value is 6 over here, C's value is minus 3, so we're going to pop in that, and under root it, and then we have 2 over 2a. A's value is 6 again, and yeah. Now, x will equal minus into minus makes plus, as you know. So plus 7 plus minus 7 squared is 49. Minus into minus again, you can see is plus. So it'll be plus. Over here, anything like, for example, you could say 12 6R or 24 3R. It's going to be 72 under root 2 6R 12, as you can see. Then we'll have x equals 7 plus minus is 11, and again we have this. Can you believe it? We have the same thing again in the root, of course. So x equals 7 plus minus 11 over 12. So that means x will either equal 7 plus 11 over 12, or x will equal 7 minus 11 over 12. So then we can write x equals 7 plus 11 is 18 over 12, or x will equal 7 minus 11 is minus 4 over 12, and x will equal, over here you can simplify this to 3 over 2, or x will equal, basically 6 3s are 12 and 6 2s are, sorry, 6 3s are 18 and 6 2s are 12, but yeah. And this will be minus 1 over 3, as 4 1s are and 4 3s are. So x, its values will be 3 over 2 and minus 1 over 3. So that's our solution set.
That's it for this video, guys. I hope it was helpful. If you have any question, comment, confusion, shoot me a message. We'll spend more time on it, and be sure to ring the notification bell so that you don't miss out on any of my videos. And you can share it with anybody that you think is struggling with quadratic equations, or you think that they might need it, so you could share it with them. And yeah, until next time, guys, peace out.